The last example that we have involves increasing and decreasing intervals again. The function given to us is going to make for a little bit of a difficult derivative. Notice I see product rule and chain rule within this problem. However, I am confident in my algebra skills, so I'm going to go ahead and distribute these pieces to make for a simpler derivative for us. So first I expanded out my perfect square trinomial and I got x squared minus 6x plus 9. Then I took this product and I multiplied it with x minus 2 to get that we are finding the derivative of f of x equals x cubed minus 8x squared plus 21x minus 18. So now let's find the derivative. I have the derivative of this function is 3x squared minus 16x plus 21. Now that I've found the derivative, I am going to set the derivative equal to 0 to find the critical points. Unfortunately, 3 does not go into each of these values, so I can't factor out a 3. However, this still is a factorable quadratic, so notice I have factored this into two pieces. So now I'm going to set each of these pieces equal to 0. I have 3x minus 7 equals 0. So I have x equals 7/3 is one of my critical points. The other critical point that I have here is x minus 3 equals 0, so we get x equals 3. Now we are ready to create a sign chart. In the last problem, we talked about how we need to consider if these critical points are in the original domain. I didn't even consider that for this problem because we were dealing with a polynomial function. We know that a polynomial is continuous on all real numbers, so both of these critical points are going to actually be critical points here. So I'm going to use these critical points, and notice I've written down my first derivative so that I can create a first derivative sign chart. So I chose 0, 2.5, and 5 to help me with my sign chart. And my first piece here, I'm going to plug 0 into my derivative, and I get negative times negative equals a positive value. Now I'm going to plug in 2.5. So 2.5 minus 3, we have a negative value. 2.5 times 3 minus 7, we have a positive value. Negative times positive, we're going to get is negative. Last piece, I have 5. 5 minus 3 is a positive value. 3 times 5 is 15. Minus 7 is 8. So I have positive times positive, which is positive. So from here, we are going to look at our sign chart. And where our first derivative is positive, we know the original function is increasing. So what we're going to write for these intervals, I have f is increasing on the interval negative infinity to 7/3. There is also another increasing interval. Notice I go from 3 to infinity, also has a positive derivative. So I also have that our function is increasing from 3 to infinity. So there are two intervals for increasing. And then we also have an interval for decreasing. So this interval, for which we will say that f is decreasing, is going to be from 7/3 to 3. To clean this up, I've written it one last time. I have f of x is increasing on negative infinity to 7/3 and 3 to infinity. We also have that f of x is decreasing on the interval 7/3 to 3. We can use our graph to verify this information. You can look at the zeros and see where is it above the x-axis, where is it below the x-axis. If you have any questions, feel free to let me know. I will see you tomorrow.